Hi, I am Ravindra from AAA department, and today the topic from HVDC transmission system is about types of filters, and this one is classified as module 2 types of filters. This one is classified as module 2 here, and at the end of this lecture student will be able to know the types of filters that are low pass, band pass and high pass filters and DC harmonic filters. Coming to the introduction part here, filters are highly essential to mitigate or eliminate the characteristic harmonic frequencies which are generated during the converter operation. Where the filters are located, actually the filters are located here in the transmission, in the converter station. Let us consider like this. This is supply, AC supply. This one is an AC supply, and this one is given to transformers, star to star connection. Another one is star to delta if it was 24 pulse converter, and this one is given to converters, right? Converter device. That is a rectifier, AC to DC. This one is an AC to DC, and again there is a link here. Again there is an inverter device. We have an inverter device connected to the load point. Here again to DC to AC. Here again to DC to AC. This one is what we known as DC link here, right? This one what we called as DC link here. Where we connect these filters. Here it is from AC to DC and here from DC to AC. This is the HVDC configuration, right? Here, where do we connect these filters? That is, here in the transformer, there are some harmonic generated. Mainly CV harmonic that is generated is third harmonic, right? To filter out these harmonics, we connect here single tune filters, double tune filters, right? AC filters are connected here. Now, where do we connect DC filters? DC filters are connected at the smoothing reactor. Here we have a smoothing reactor of the conversion bus. At this end, there we connected some DC filters, right? We connect AC filters and DC filters in the HVDC system. This is the configuration of HVDC system. Where the AC filters are connected, and these are connected to the ground here. Again here connected to the ground. Okay, that means here provided the low impedance path, the harmonics that are generated move through the filters through to the ground. That means here AC filters or DC filters, the provided impedance is low compared to this transmission line impedance. We take the path of the whatever the harmonics that are generated takes the path of low impedance path and move into the ground. Okay, here the AC filters are there and DC filters are there, and these are arranged at the converter stations as well as inverter stations like this. Here before the AC filters are arranged at the near the transformers and the AC converter valves, right? And DC filters are arranged at the smoothing reactors. That means after conversion from AC to DC, there like that, right? And these and inverter stations to reduce the magnitude of the harmonic currents. To reduce the magnitude of harmonic, why we say they reduce the harmonic currents magnitude of the harmonic? Because here the third harmonic which has the highest magnitude, the third harmonic that is generated at the transformer has highest magnitude. To reduce this lower order harmonics, to reduce and eliminate this magnitude of this harmonic currents, to eliminate them by discharge them to the ground. Here actually in case of this why we use these filters, mainly the low order harmonic currents have high magnitude of currents. Low order harmonic currents have high magnitude of currents. To remove them, we use low pass filters. That is nothing but single tune filters and double tune filters. Those filters are used here to filter out these all harmonics, right? And the filters use the passive components. What are the components that are used here? Passive components like resistors, inductors and capacitors here. Okay, they are designed to remove the unwanted frequencies and to reduce the telephone interference. These are due to the harmonics generation, that means nothing but unwanted frequencies that are generated, and these are removed by using these filters. And not only these harmonics, these are used to reduce the telephone interference, right? And DC filters along with smoothing reactor, what does the smoothing reactor does? It removes the ripple content in the DC system. It removes the ripple content in the, that is after conversion AC to DC, whatever the ripples that are produced when the conversion process, that ripple content can be reduced by using these smoothing reactors. Okay, these ripples can be reduced here or are eliminated here. The filters AC and DC in HVDC systems are connected between the phase and ground to bypass all these currents. These currents are connected to the ground. Provided the low impedance path through the filters, these move to the ground here. That is the thing here. Okay. And what are the types of filters? What are the types of filters we have? We have low pass filter, high pass filter, and band pass filter. These are the three types of filters. General filters. This is what we call a general classification. This is a general classification of filters. Low pass filter, high pass filters, and band pass filters, both in case of AC and DC we can consider. Okay. These are three filters that are used. Now let us classify one detailed class. Let us consider low pass filter. Okay, in low pass filter, this is the circuit. We have a resistor connected to the capacitor. See the capacitor shunt to the ground here. Capacitor is shunt to the ground here. See, resistor connected to the capacitor shunt to the ground here. And this is what we call it as low pass filter. This configuration of resistor and capacitor is called as low pass filter. And the lower order characteristic harmonics. Here lower order characteristic harmonics. So what is the lower order characteristic harmonics means? The first, that means third, we have even harmonics, odd harmonics. Okay, let us consider odd harmonics. What are the lower order harmonics? We have third harmonic, fifth harmonic, seventh harmonic. These are all lower order harmonics. If you consider 12 pulse converter, the lower order harmonics are third, fifth, seventh, and 11th harmonic, right? Those are the lower order harmonic harmonics. Here, when you compare with lower these harmonics, the magnitude of the lower order harmonics will be higher. That means here third harmonic magnitude will be higher compared to that of fifth harmonic. Fifth harmonic magnitude will be higher compared to that of seventh harmonic, like that, right? As the order of the harmonics increases, the severity decreases here. As the order of the harmonics increases, severity decreases here. Okay, which are the formed here? The lower order characteristic harmonics are formed during the converter operation are more harmful in nature than higher order harmonics. That's what we are saying. That is, the order of the harmonics increases, severity decreases. The lower order harmonics, that is third harmonic, is most severe. That means it is more dangerous compared to the fifth and seventh harmonics, right? And hence the low pass filter is designed to filter out all the lower order harmonics by diverting them to the ground. Everything is diverted to the ground, provided a ground path here, right? And when you consider this one, this is the resistive bank and C is the capacitor bank. Ith harmonic current is passed through this one to, that means here the capacitance as well as resistance provided the low impedance path to pass this lower order harmonic here. And now see this one, a low pass filter is basically a RC circuit, that what we are seeing. And low pass filter offers very low capacitive reactance for a lower order harmonics and provides a very high capacitive reactance for higher order harmonics. That means when you consider here, see this one, this is the WC, what we observe here from the diagram. It is drawn between frequency, cutoff frequency here, WC is nothing but cutoff frequency, omega represent with omega, and V0 by V1 gain represent with respect of gain and cutoff frequency, right? Now here if we observe here, cutoff frequency is WC, okay? It does not allow to pass through the, it allows only the lower order frequency. Below 11C it allows to pass through. The frequency which is in between 0 and WC, it allows to pass through. After WC it does not allow to pass through. Okay, in low pass filter allows only low frequencies. It allows only to pass through harmonics, the content that has low frequencies, that is in between from 0 to WC, it allows to pass through. After that one, after cutoff frequency, it does not allow, right? From the frequency response of LP filter, it is observed that the filter allows lower frequencies and blocks all other ones above the cutoff frequency. That means above cutoff frequency, it blocks. Only it allows the frequency in between 0 and WC. That is cutoff frequency. It allows the frequencies only between 0 and WC and blocks the frequencies above WC. This is about low pass filter. And this one is the frequency response of LP filter, that is drawn between gain and frequency. Okay. And WC is noted as cutoff frequency. Now coming to high pass filter. Now see, there we have drawn between resistor, we provided a resistor bank in case of low pass filter and a capacitor bank. Now when you come into high pass filter, here provided a capacitor and a resistor in parallel with inductor. And this totally we call it as 8 core reactor. This one is an 8 core reactor, this part, and this resistor bank. This one is a resistor bank and provided to the ground. That means here a resistor and a 8 core reactor, and both are, these two are parallel in series to the capacitor. This total is called as an high pass filter. That means this total thing is provided a low impedance compared to that of high transmission line. Okay, and these filters allow all the higher order harmonics frequency and restrict all the lower order harmonics. These are also called as damped filters. These one are also called as damped filters. It allows only high pass filter, only high pass frequencies only. It allows only high frequencies. It does not allow lower frequencies to pass through, and that is in the range between 24 and 61. The order of frequencies that is harmonic order in between 24 and 61. That means if it is if it does not allow third harmonic to 19th harmonic, right? 17th harmonic. It does not allow up to till 21 harmonic, 21st harmonic, right? It allows only from 24 to 61 harmonics. It allows only from 24 to 61. This one what we call as high pass filter. That means it has only a frequency of order 24 to 61. And harmonics of order 61 above are harmless as the magnitude of their currents is very small. Here the magnitude of these currents is very small here. That means there is no need to another filter to design for 61, more than 61. If the order is higher than 61, there is no need to design any filter because there is no severity here. As what we consider is as the order of harmonic content increases, the severity of the harmonics will be decreased, right? In that case, if there is more greater than 61 order, there will be no severity. So why need to any filter? There is no need to have any filter there, right? And does not affect the overall performance of the system. There is no problem. The HP filter diverts all order characteristics as well as non-characteristic harmonics to the ground. It allows only characteristics and as well as non-characteristics. Characteristics are order harmonics, non-characteristic harmonics are even harmonics. Those both even harmonics are nothing but 2, 4, 6, 8. Those are all even harmonics. Odd harmonics 3, 5. These are all odd harmonics. Both it allows move to the ground. Provide a low impedance path. Now you see the diagram here. It allows only high order harmonics, that is WH greater than 24. Here the cutoff frequency is WH here, and the gain, it is drawn between the gain and WH. Omega frequency WH, here cutoff frequency is WH here. It allows only greater than 24. It allows to pass the frequencies greater than 24, order 24. It allows only pass through this one, right? These are nothing but high pass filter characteristics. Okay. H greater than 24. Only it allows H greater than 24. And these will be blocked from 0 to 24. Cutoff frequency 24. These all will be blocked. the frequencies in between 0 and 24 will be blocked, and allows it pass through greater than 24. It allows. That means it is greater than 24. The harmonics of are greater than 24. It allows to pass through. Okay, that is the thing here. That means here this filter has been designed in such a way that it does not allow low order harmonics. It allows only higher order harmonics. Okay, that is the filter here. And coming to band pass filter, see the diagram here. One low pass filter is connected. Here a low pass band pass filter is made up of combining low pass filter and the end of high pass filter. We can see high pass filter and as well as low pass filter. End of the high pass filter, we have connected this band pass. See, band pass filter is made up of combining low pass filter on the end of high pass filter. Okay, these are made a resistor, inductor, one inductor, another resistor. These are connected parallel to the L2 and in series to R1. These are connected parallel to C2, connected in series to R1. Okay, this is the capacitive band pass filter, what we consider as. This is the inductive band pass filter. Inductive band, that here band pass means range of frequencies. It allows only certain range of frequencies. Okay. Band pass filters are designed to bypass certain range of harmonic frequencies which are neither too high nor too low. Let us see here. See the diagram here. These are drawn characteristics, gain between the gain and frequency. Now it blocks from 0 to FH. It blocks. Okay, from frequency from FH to FH it allows. And here again it blocks. That means here in the range of FH and small fh and capital FH, here only in this range only it allows to pass through. The frequencies are allowed to pass through only if they are in this range only. This filter is non-reactive to harmonic frequencies from 0 to FH. That means it blocks from 0 to FH. It does not allow to pass through. The band pass filter allows the range of frequencies falling between FH and small fh and capital FH. Only if that order of harmonics are in the range of FH and small fh and capital FH, then only it allows to pass through. That means this is the range of frequencies. When they are in the range of these frequencies, it allows to pass through. That means the order of frequencies, harmonic frequencies are in the range of, that means range of frequencies only it allows to pass through. From 0 to FH it does not, it blocks, and from FH to another end it does not block. Only range of frequencies are allowed to pass through this band pass filter. Okay. Now coming to, those are about, we have discussed about types of filters. We have low pass filter, high pass filter and band pass filter. Low pass filter means it allows the frequency of all low order frequencies. It allows all the frequencies which are low order frequencies. High pass filter means it allows the frequencies which are higher order, greater than 24. You can consider harmonic order greater than 24. It allows higher order harmonics greater than 24 and below 61. That below 60, we cannot say below 61. All higher order harmonics can be allowed to pass through high pass filter. Band pass filter means certain range of frequencies. Certain range of frequencies. If it is between 17 to 30 or 30 to 40, in certain range of frequencies, it is allowed to pass through. Okay, that is considered. Now these are the three general types of filters what we have discussed now. Now coming to DC harmonic filters. What is DC harmonic filters? What is its purpose here? These filters are placed near to the smoothing reactor, right? These are placed in the DC, after the conversion from AC to DC, after we have obtained a DC voltage, these are placed to minimize the harmonic contents. and here mainly to reduce the ripples, mainly to reduce the ripples in the DC line, and also telephone interference. What is meant by a ripple here? Let us consider a ripple, nothing but here, suppose actually what is the purpose of converter? Convert to the AC to DC supply, right? That means here when it is a sinusoidal waveform, when you consider a sinusoidal waveform, in a sinusoidal waveform, it is a rectified, full rectified waveform what we consider. It is not fully converted. That means the suppression from AC to DC is not there here. That fully it actually a sinusoidal waveform. It is a sinusoidal waveform. Let us consider this is a sinusoidal waveform. This is the AC supply. It should be converted to DC. That means it should be a straight line. But we are not obtaining here straight line. What we obtain here, like this. What is this content here from here to here? This is ripple. The ripple content is produced here. We are not exact, the DC supply is not produced here. They are produced as some ripple here. Exact DC supply is not produced. It says they are produced as some ripple here, ripple content. To smooth out this ripple, we use smoothing reactors and also DC harmonic filters. Combined with DC harmonic filters and smoothing reactors, these ripples can be eliminated. This is the main purpose of using these DC harmonic filters, to smooth out or to eliminate this ripple content, so that we can obtain exact DC voltage or DC current, right? That is the main thing, and minimization of these telephone interferences. And these filters are intentionally made in order to avoid resonance. Why to avoid resonance here? Actually, there is, we have some impedance to this transmission line. In case of AC we call it as impedance, in case of DC we call it as some resistance values. We have some resistance value to this one. Suppose if we connect any filter here, we connect any filter here, the impedance of this filter, the impedance of this filter and impedance of the transmission line should not be equal. If this one is both are equal, there is a chance of occurring a resonance problems. There is chance of occurring a resonance problems. To eliminate that one, what we do is, here the impedance of this filters is made very lower one. That is made, the filter impedance will be very low compared to that of this transmission line impedance, and it takes the path of that filters. Any harmonics or any